10th Physical Science, Electric Current. Today we are going to learn about the potential difference, electromotive force and working of battery. Before connect the wire with battery, there is no change inside the wire. When this conductor or wire connected to the battery, then the unit charge inside the conductor moves from one place to another place. So here we see the work done. Which type of work done is seen here? The unit charge covered distance. So here the distance is denoted by a L. So the unit charge covered the distance from one end to another end. So the work done by electric force to move charge from one place to another place is called potential difference. So when the unit charge move from one place to another place, during this period electric force is created inside the conductor. So this electric force made the unit charge moving one place to another place. So the principle of the work, W means work, is equal to Fe. Fe means electric force into L means distance. And V means potential difference. And this potential difference is also called voltage. So voltage is equal to W by Q. W means work done and Q means charge. And V is equal to W means already you know Fe into L. So here also we can see Fe into L by Q. So this is a principle of voltage or potential difference, and this voltage measured in volts. So the volts is equal to 1 joule and by coulomb, 1 coulomb. 1 volt is 1 joule by 1 coulomb. Electrons passes from low potential to high potential, and current passes high potential to low potential. So here two types of process can be seen here. So in this diagram, the conductor connect to the battery, and one end we can see the high potential difference and another end low potential difference. So here the electrons passes from low potential difference to high potential difference, and the current passes from high potential difference to low potential difference. It is like a two bottles seen here. So in first bottle the water level is higher, and in the second bottle the water level is low. These two bottles are connected with a small pipe, and below first bottle another pipe is connected, and through this pipe the water is supplied. And the first bottle, when it has a water level high, so the excess water flows through this pipe and reaches to the another bottle. So here when the two water levels on both bottles are equal, then the water not goes from one bottle to another bottle. So when the water flows high level to low level, so it is an example for the potential difference. When the water supply through this pipe into first bottle, so this supplying water is example for the electromotive force. The charge also move high potential to low potential, and potential difference is also called voltage. So the charge also moves from high potential difference to low potential difference. Next one, electromotive force. EMF means electromotive force. So here also we can see the work done. So the work done by unit positive charge from move negative terminal to positive terminal is called EMF. It is happens in battery. So it is a battery. So it has a one end high potential difference and another end is a low potential difference. So here inside the battery we can see the chemical force created inside the battery. So inside the battery the electromotive force. So this electromotive force is created, so that made the work on the unit charge move one unit to another unit. And the principle of electromotive force is Fc into L. Fc means chemical force and L means distance by Q. Q means a unit charge. So the unit charge present inside the battery moves by the chemical force from one end to another end. So it is called electromotive force. So the chemical force made the unit charge move one point to another point. So it is called electromotive force and it happens in the battery. Next we can see the potential difference. It happens in the wire, and here electric force made the unit charge move one place to another place. So we seen the difference between the potential difference and electromotive force. In battery, chemical force use it in the battery to move the unit charge, and potential difference electric force is seen to move the unit charge moving from one place to another place. So this is the difference between the potential difference and electromotive force. Now we can see the working of battery. In the battery, two metal plates present on both sides, and they are called anode and cathode. So in the first diagram we can see the diagram of battery. So inside the battery, both sides we can see the metal plates. One is anode and second one is cathode. Electrolyte, it means chemical spread inside the battery. So between these two metal plates, chemical is there. It is called electrolyte. Positive ions and negative ions always want to move towards the metal plates. So here inside the two metal plates, positive ions and negative ions are there. So by the force of electrolyte, all of these ions pushes towards the two metal plates. Positive ions and negative ions ready to move respect metals in battery. So by the force of electrolyte, positive ions and negative ions ready to move towards the both metal plates. Chemical force and electrical force. Electrical force produced inside the battery moving appear as a opposite direction. So when the positive ions and negative ions want to move towards the plates, during this period the electric force is also created inside the both metal plates. So here ions start moving towards the plates. The motion of the ions continue towards their respective plates till electric force and chemical force shows equal. So what is the work of chemical force? The chemical force pushed the ions towards their respective plates here. So when the Fc and Fes both are equal, then there will not be any motion in ions due to balance of forces Fe and Fc. So here the positive ions goes towards the metal plate and accumulated on this plate, and the negative ions also goes towards the another plate and accumulated on this metal plate. So till the balance of forces, electric force and chemical force equal, so then there will not be any motion in ions due to balance of forces, electric force and chemical force. This situation we can see in new battery that we buy from the shop. This is the reason for the constant potential difference between the terminals of a battery. So this position can be seen in the new battery when we buy from the shop. So in the first metal plate can be seen on the metal plate accumulated the positive ions, and another metal plates also contain so many negative ions. So there is no motion in the ions because balance of the chemical force and electric force. And both ions in the electrolyte shows balanced forces in new battery. So there is no motion of the ions can be seen in the new battery. When connect the wire to the terminals of the battery, potential difference is created between the conductor. So here we can see first the battery cannot connect the wire, so there is no change in the moving of ions in the battery. But when we connect the battery with a conductor, so automatically the bulb also glowing brightly. So here the potential difference is created between the two metal plates. So high potential difference and low potential difference is there on the both ends of the battery. And here we can see the potential difference set up a electric field throughout the conductor. So when connecting the battery with a wire, automatically the electric field is set up throughout the wire. Here we can see the electrons moves from negative terminals to positive terminals. Electrons are moves from negative terminal to positive terminal, and the electric field passes from positive terminal to negative terminal. So when the electrons are passes towards the positive terminals, here the electric force is decreasing. Then the electrolyte pulls the electrons from this place and pushes towards the negative terminal. So the excess of electrons goes through this conductor. Okay, so all these electrons are goes through negative terminal to positive terminal. So when these electrons are passes throughout the wire, so the electric field is passes through the positive terminal to negative terminals. So here we observe that direction of electric field is seen positive terminal to negative terminal. Electrons moves from negative terminal to positive terminal till attain equal forces Fc and Fe. So here also we can see the balanced forces, chemical force and electric forces. Okay, so here we can see the electric field is formed inside the battery and conductor, so the bulb glows brightly. So all these are working of battery.